Hi, and welcome to the Northern Forest Biomass Project Evaluator tool. This tutorial is for version 4.1, which includes some new features for estimating how many acres in your study area are inaccessible for timber harvest. As always, you begin on the Data Setup tab. This is where you choose your study area, either by county or via a circular area. In this example, we'll choose 3 counties in central New Hampshire. Now that our study area is selected, we'll skip to the second Key Assumptions tab, which is where we will find the new feature. On this tab, you set the percentage of acres in your study area that fall within different ownership categories, as well as the percentage of accessible acres that are not available for harvest due to various physical constraints, such as steep slopes, high elevation, limited harvest within stream buffer areas, and so on. The assumptions in Part B can sometimes be difficult to estimate, but the new BPE feature, which you see below, will provide you with some real data for these inputs. So if you're unsure about how many acres may be inaccessible for these reasons, you'll want to click this blue button. As you can see, it opens a separate form that lists each county you've selected and the percentage of the acres in that county that fall into each category. So for example, 0.15% of Merrimack County has slopes that are too steep for harvesting. Another 4.66% of the land area is in stream buffers, and almost 8% is classified as wetlands. The data you see here were generated as part of a study entitled Analysis of Wood Resource Availability in the Northeastern United States, which was funded through a 2013 grant from the Northeast States Research Cooperative. In this case, steep slopes are areas with a percent slope greater than 50%. High elevation are locations greater than 2,700 feet. Wetlands were identified via the 2011 National Land Cover Dataset. Areas far from roads were defined as places a half mile or greater from the nearest road. Stream buffers were calculated based on the slope of the land immediately adjacent to each water feature and the corresponding recommendation for buffer width from the Voluntary Best Management Practices for the Protection of Water Quality in a particular state. Finally, conservation restrictions were based on data from the National Protected Areas Database and the National Conservation Easement Database. There's much more detail available on the data analysis in the Model Help section. A brief note before we move on to actually using this information to inform our key assumptions. The total here reflects the amount of land that falls into one or more of these inaccessible categories, and it was derived from the same spatial analysis. So the total is not necessarily equal to the sum of all individual categories, because certain lands may fall into more than one category. For example, an area may be far from roads and protected. So this total is a better estimate of the total amount of inaccessible land area in the entire county. The most useful numbers on this form will probably be the average values listed at the bottom, because these give you a sense for the average accessibility constraints across the entire study area. It's also worth noting here that this form is showing you the percentages for entire counties. So if you've selected a circular study area that overlaps portions of several counties, you'll need to keep that in mind. For example, if only a quarter of your circular study area falls within Merrimack County, remember that the values here represent all of Merrimack County, not just the portion that you selected. This is where you'll have to use some of your knowledge of the study area and expert opinion to get at a more accurate value. Another useful number to focus in this form is the total percentage average. This is the total value that we want to be aiming for as we're tweaking the numbers in the second Key Assumptions tab. When you're ready, you can simply click the Close Form button in the upper right to close out. Back on the Key Assumptions tab, I will adjust these values to more closely reflect the real-world data we just looked at. You'll notice that with the default values set the total percentage of physically inaccessible acres is 5%. But we want this value to be closer to 22 based on the data. And now that I've made the adjustments, you'll notice that the total percentage has come up to closer to 23%, which is more in line with the measured data. And if we click to open the table, we can see how those key assumptions have been applied. At this point, you're ready to click Apply Key Assumptions in step 4 and move on with creating your model run. But now you can be a bit more confident in your selection of the assumptions in Part D, because they're based on a spatial analysis of actual conditions. And again, if you'd like more information, click on the Model Help button in the upper right, then click on the tab farthest to the right, labeled Inaccessible Acres. And here you'll find much more detail on the analysis that was used to generate the values in the new BPE feature. And this concludes the BPE version 4.1 tutorial.